Hey, what's going on, guys? We have a linear finite object right here. So this is linear, the finite line, finite length, and the question is asking to find the electric field at this location right here. So let's see how we can find this one. So first of all, to find this one, what we do, we take a segment right here, small segment, and that is going to be okay. So we are going to have a small segment, and here we are going to have a small charge, right? That charge, we take this one as dq, and also from here the distance from here to here, if I take this distance x, this small distance is going to be dx. Therefore we can say dq is equal to lambda times dx, right? Lambda is linear charge density, so lambda times dx gives us the small charge right here. Also this is a positive charge, and if we draw the line, this is going to be having a direction in this way. So this one we can call DE, and if you take one segment right here, we are going to have to take another segment right here too. So this is going to be something like this, and that's going to be another way. That's also a DE. Since we are taking the equal distance, both are divided into equal distance, and then this is x, and this is also going to be x, and we have this a, and let's say this is r length, this is r, this middle part is a, middle length is a, and this since this is in this direction, these are going to have two components. The first one is going to have component in the upper direction, dey, and x direction, so this is dex, and also the bottom part is going to have two components, that is dey and dex in the same direction. And if you look at this, since both are equal in every way, this ey and ey will cancel because both are in the opposite direction, so both will cancel, so we don't have to worry about the y components, those will cancel. So we only have to find out x component, and if we find out the x component, that's going to be the electric field in this location. So let's calculate these things. So first of all, what I'm going to do, I'm going to create an equation for the electric field, dE. So this is what we are trying to calculate, right? So dE is equal to k dq over r square, right? It came from kq over r square. Since we are taking dE, we are taking k dq over r square. Here we know that dq is equal to lambda dx, so we can replace that one with this. So this one will be k lambda dx over r square. R, you know that if you draw a line right here, and according to Pythagorean theorem, so we already know this a, and this is x. So therefore r square is going to be a square plus x square. Since we have r square in the bottom, we can replace this one with a square plus x square. So a square plus x square we have right here, and that is the equation for the dE. So if this is dE, what is dEx is going to be? So let's say we have the angle right here, theta, and if this is theta, this is going to be theta too. So if that is theta, then we can say dE cos theta is equal to dEx, right? So let's continue this one right here. So dEx is equal to dE cos theta. So for the dE, we just copy this thing, that is k lambda dx divided by a square plus x square. Cos theta, if you draw a line right here, cos theta is what? Adjacent over hypotenuse. We know this hypotenuse is r, right? Hypotenuse is r, and then we know this distance, that is a, adjacent is known, hypotenuse r. We know that r is going to be equal to square root of a square plus x square. So we can replace the cos theta with cos theta is equal to a over square root of a square plus x square. So we can replace this one by that. So this is going to be a over square root of a square plus x square, and in this case a square plus x square power square root means it's power half. 1 plus half is going to be 1.5, so it's going to be 3 by 2. So we can add them together. So let's add them together. So k lambda a dx is over a square plus x square power 3 by 2. Now we have dex, but we are trying to find the ex, right? Since this is in dex, if I integrate that one, I will get the ex. So let's integrate that one. So so we are trying to calculate the ex. So we know the full length is L. So what I'm going to do, I'm take the half length of this one, that is L by 2, because both are in the same exact distance. So I'm taking from the middle only this top part, L by 2, and if I use that one, this is going to be 2. We have to multiply by 2 because we have L by 2, that's going to be 2 times. So let's take the limit integral from 0 to L by 2. So if I take this one and let's substitute dex, we are trying to find dex, integrating dex, and that's gonna be 2 times. I just replace all the values right here. We know this dex is this whole thing, right? So I replace this one with that. So this is gonna become 2 integral of 0 to L by 2 k lambda a dx divided by a square plus x square power 3 by 2. We know that k, lambda and a, all of them are constant, so we can move it in front of the integral. So this is going to be 2k lambda a integral of 0 to L by 2 dx divided by a square plus x square power 3 by 2, right? So this is what we have. Now all you have to do is simply integrate this one. So let's see what happens if we integrate. So if I integrate this one right here, that will give us 2ak lambda x over a square x square plus a square power half. So this is what I get when I integrate, and this is 0 to L by 2, right? 0 to L by 2, and if you see that we have an a square in the bottom and we have an a in the top, so we can cancel those together, cancel those and bring the a to the others here, because a also a constant. We can bring that one right here. So if I bring that one, it's going to be 2k lambda over a, and here we are going to have x, in the bracket we are going to have x over a. I took the a already, so this is going to be x over x square plus a square power half. So let's continue on top. So this is what we have right now. So now we can simply, so this is from 0 to L by 2. We can simply substitute the L by 2 for the x value and 0 for the x value. If I substitute 0, that's going to be 0. So first let's substitute the L by 2. So this is going to be 2k lambda over a. For x, I'm substituting L by 2 over L by 2 square plus a square power half. and then if I substitute 0, this whole thing will become 0, so that doesn't make any difference. So I also here I can cancel this 2 and this one, so we will be left with k lambda L over A times 1 over L by 2 square plus A square power half, and that is our final answer, and that is in x direction. So we can say E is equal to this one in the x direction, and let's box this one. This is our final answer. I hope you guys like this video. See you next time.